Hello and welcome back. Today I would like to talk about the tolerancing systems inside the drawings. Whenever we're going to make the drawings of any object, so we must know about the tolerances, right? So in simple words, sometimes we can call this as the GDNT, geometric dimension and tolerances, right? So what's actually the tolerance means over here? Take something a bit higher, larger, or a bit smaller or lower in amount of the actual size, right? So why we're giving this, let's talk about these things, right? So the use of the tolerance is to just control of position of feature within parts, control of form or shape of feature of specified portion of the part, right? So but sometimes certain industries have very limited tolerance, or even they just skip about the tolerance, right? They don't have any tolerance in case of the aviations, in case of the precision industries, right? So we have this object, as you can see the diameter is given, and you can see over here the distance part. This is the bilateral tolerance. You can have positive and negative. You can have lower or higher of 0.2. So this could be 25.2 or 24.8. You can have these examples, right? And there are subsamples used whenever we are going to deal with the tolerance systems. We have straight, we have flatness, circularity, cylindricity, profile of a line, profile of a surface, angularity, perpendicularity, parallelism, position, concentricity, circular runout, and total runout, right? We have these one, which are the abbreviations for modifying symbols, right? So you can just look at these things. And use of datum is earlier in the previous lecture I told you that we are going to use the datum plane instead of measuring each and every point from the reference point. So that would be really looking a very congested line. Instead of going towards that, we're just going to define a proper plane. With that, we're just giving the dimensions, right, as you can see over here. So this is what actually I talk about. Next we can have the datum planes in space, right? So you can make new planes in space to make sketch on that or anything. You can create planes. That's what actually we call it the reference plane, right? So if you select this top piece, with this you can actually make the planes in the space. Positional tolerancing, right? So here actually I'm positioning this hole with reference to this line, right? So this will actually the main idea over here, right? And the diameter is 0.4, and tolerance on the location of the hole is independent of the tolerance on the size of the hole. Okay, so here one point we should know about is that if you look at here, so we have just given the tolerance to the hole, not to these dimensions, right? So these dimensions are independent of the hole tolerance. We can have this example. We have a circular array. We have the concentricity. If you just make two circles have a common center point, what actually we can call that is concentricity. In this case we have the same, we have different sections with revolution, so you can think of it, right? We have the straightness, simple as this one, and we have the flatness, this is opposite of the roughness. We have roundness, right? And this is actually the proper contour profile, and this, and if you look at here in section AA, so this is not the proper one, but this is actually a variable contour. You can think of it. Cylindricity, simple as this one. Profile of a line, actually what's actually profile means the exterior of the body or the outlines. Consider, you can imagine over here, and this is in fact what actually we can call this is the profile of an object. Profile of a surface, you can see the exterior path, that actually a cutting tool path during finishing of a surface is known as the profile of the surface. Angularity, if we have certain angle. Perpendicularity, simple as this one, and sometimes this will actually be known as, we can have this top view and we have the projection view over here. Alright, what is actually the runout? A measure of the deviation from perfect form determined as a part is revolved 360 around S-axis. The runout may be found by reading the interchange on a dial indicator while a part is revolved one full turn. This reading found is FIM, full indicator reading, or TIR, total indicator reading. So we can have two types of runout control, example circular and total. We have the next lecture. Right, so I think we have done most of the work, and we have the tolerancing systems. We have a rectangle inside a circle, and it must probably having certain extrusion height. So we have the, you can see over here, right? This is the diameter 0.5. So here we just given 0.08 tolerance in the positive direction. Types of journal fits. What is actually mean of fit is over here, the interaction between the hole and shaft is what actually we call this as fit. In common science, sometimes we will just build something, and when it looks fit on you, that's what actually the interaction of you with a certain thing, which is called suit over here. So we can have the clearance fit, interference fit, and transition fit, right? And clearance fit, make sure that the diameter of the hole must probably be larger than the diameter of the shaft. And interference fit, it is opposite of the clearance fit. Sometimes interference fit also called the press fit, okay? And transition fit is in between these two. It is not that much of the press fit, right? Or nor it is just like the clearance fit, right? But it is in between these two. As you can see over here, the clearance fit, right? We have the shaft, we have the hole. The hole diameter is larger than the shaft diameter. So once you make the interaction in between the two, probably you will get a looser connection. So we have the other example, interference fit. The hole diameter is smaller than the shaft. You must probably press this shaft to put it inside this hole. Transition fit, okay, it has some intermediate value, not too larger, not too smaller, right? So the connection or the fit and between the shaft and hole in this case is the intermediate one, right? And we have some of the definitions like the nominal size, what comes in mind, right? If we think of something in general, that for example I just say that the diameter of the shaft is 20, so I'm not talking about the specific diameter. It may have certain deviations, but I can call that as the nominal size, basic size, right? The actual size you can say that, and limit of the dimensions, the values that you have just assigned, and the positive and negative direction, or in case of the lower limit and higher limit. And tolerance, actually this is the difference in between the limits, right? So bilateral tolerance, which is in both directions; unilateral tolerance, which is in the single direction, either positive or negative fit, as earlier I told you; clearance fit, interference, transient allowance, which is a very common factor, and you have to be a clear out idea about this thing, right? An alternative term for the tightest possible fit, that is minimum clearance or maximum interference, is called allowance, right? This is very simple. And sometimes we can have allowance in the metallurgy as well, like to keep the metallic size a bit larger than the actual one, because in the winter seasons, right, things get shrink, and because of that we get a bit of the lower size of the object. And basic hole system and basic shaft. So in basic hole system, a system in which the basic size appear is one of the limit dimensions of the hole, but not of the shaft. And in basic shaft system, at which the basic size is included as one of the limit dimension of the shaft, but not of the hole, right? So in basic hole, we're just focusing on the whole dimensions, but in basic shaft we're just focusing on the shaft dimensions to control them, so that to get the proper connection. Maximum material condition, the condition in which a hole is at its smallest limit dimension and a shaft is at largest limit dimension. So this condition exists at a minimum clearance or maximum interference, right? So if you take shaft of the maximum possible diameter, they can make connections with the hole. So that what actually we can call it the maximum material condition. And opposite of this is the minimum material condition, the condition in which a hole is at its largest limit dimension and a shaft at its smallest limit dimension. This condition exists at minimum clearance or minimum interference, right? So we have the cumulative tolerances, right? If we sum up all the tolerances within an object exist, so then what actually we can call them is the cumulative tolerances, right? We have this object with holes, and we have just dimensioned them. We have the other prismatic part over here, dimensioned them along with the given tolerances, right, in a certain range. So this is all about today's lecture. So hope you enjoyed this and you got something important from this lecture today. See you in next video, and subscribe to the channel. Thank you.